Hello guys, in this video we are doing inverse of exponential function. So we must know what is the inverse of an exponential function. Inverse of an exponential function is a logarithmic function. So let's have an example. Suppose we are given f of x is equal to 2 power x. So what we do when finding inverse, we write down this one in form of y is equal to 2 power x. So step number 1, interchange the variables. Our variables, which is x and y. So this one will be xc is equal to 2 power y. From there, make y the subject. From making y the subject, so we can take it to our left hand side, becomes 2 power y is equal to x. So, but our y is an exponent then. The only way we can do to drop this y from being an exponent is by applying a logarithm. So we apply log both the sides. It comes to a log 2 power y is equal to log x. When you apply log, what you do on the left hand side is what you do on the right hand side. Then by one of our laws of logarithms, this y is going to drop. It becomes log 2, which is equal to log x. We need y, so we need to divide by log 2 both the sides over log 2. But this one, it can cancel out, it gives you 1. So y is equal to log x over log 2. But this one is not simplified, so can't leave it like this. Y is equal to, this is the apply change of base law, which is the law of logarithms. So apply change of base law, this one becomes the base of that log. So simplify to log 2 base x. So since we are given it in function form, so the final answer is f inverse of xc is equal to log xc base 2. This is our final answer. If we find the inverse of a logarithmic function, we still get an exponential function. This is an example. Find the inverse of f of x is equal to 2 power x minus 1. So first thing, we write it in the form of y. Y is equal to 2 power x minus 1. And from there, we need to interchange the variables. So this will be xc is equal to 2 power y minus 1. From there, we want to make y the subject of the formula. So we can take this one, this side becomes x plus 1 is equal to 2 power y. Then we want to drop this y, we only drop it by means of a logarithm. So we apply logarithm both sides. Here you can put brackets to make it 1, because it's to make it 1 term. So this will be log xc plus 1, which is equal to log 2 power y. And from there, we need to drop this one by that law of logarithm, where if you apply log, the exponent drops. So log x plus 1 is equal to y log 2. So now let me write this one on my left hand side, this one on my right hand side. So y log 2 is equal to log x plus 1. Then we divide by log 2 both sides over log 2 over log 2. Then log 2 and log 2 cancels. We'll be left with y is equal to log x plus 1 over log 2. But this one, we can do change of base law here. Change of base. So this becomes log 2 x plus 1. So our final answer will be y. It's fine. Since it is inverse, f prime of x is equal to log 2 x plus 1. This is our final answer. Parabolic functions. So calculating inverse of a parabolic function, we need to follow the same stages as we did in calculating inverse of an exponential function. First step is to interchange the variables. Then from there, you need to make y the subject. Then you check whether the inverse is to a function or not. So let's see how we can do it. Let's say we're given f of x is equal to x squared. This is a parabolic function. So we write this one in form of y is equal to x squared. And from there, you interchange the variables. Let me just rewrite the steps. Number 1, interchange the variables. Our variables are x and y. Step number 2, make y the subject. So here we interchange the variables. So x is equal to y squared. But we want to make y the subject. So let me write it on my left hand side. So here to remove this one, y squared, we need to apply the square root. Apply square root both the sides. So y is equal to square root of x. That will be our answer. But we need to check whether our inverse is still a function or not. From definition of a function, we know it must be one-to-one mapping. It must be, it's either gives you, if you input one input, you must get one output. So one-to-one mapping. Or it might be many to one. Let me say many to one. There's no way a function can give you two outputs. You only need one output. So this one, let's have an example. Let's say our input is 1, e.g. x is equal to 1. So what will happen here is that y is equal to square root of 1. What is the square root of 1? It's 1, but we can't say it's 1 because we are leaving plus or minus 1. So this will be plus or minus 1. It's our output. So now it is giving us more than one output. So it is no longer a function. Also, we can prove it by using vertical line test. So this graph for square root x, it is not like this. It will be tend to form something like that. So a vertical line test, it is used to check whether the equation is a function or not. So a vertical line test, if it is a function, it just have to cut one point of your graph. So in this case, let me label it. Y is equal to root x. Vertical line test will go like this. It is cutting at this point and that point. So y is equal to root x is no longer a function. So you can't write it as f inverse of x like this. That would be not true. You just have to leave it here as a graph. It's just a graph. It's no longer a function. This one is a parabola. It looks like this. Vertical line test is just cut at one point, and this one to prove us that this one is a function. Also, if we input one or more inputs, we still get one output. For example, if we input x is equal to 1, our answer will be y is equal to x squared. What is 1 squared? We get 1. If we input x is equal to minus 1, minus 1 squared is equal to 1. So many inputs are giving us 1 output. So that's a function.